Suppose you have an investment that pays you a fixed amount every month and that also earns interest every month. What we'd like to do is we'd like to have an initial investment that keeps everything in balance, where the interest earned equals the amount that we take out so that we can continue to make withdrawals indefinitely without ever actually depleting the principal amount. Right? So let's look at an example here. Right? What we're talking about is an investment that starts off with a fixed principal. Right? We put a certain amount in the account. It earns a specified interest rate every month and has money withdrawn at regular intervals. The name for this kind of investment is an annuity. All right, so what we want to do here is we want to come up with a mathematical model, a dynamical system that models this kind of investment. Then we'll think about what we can do to actually answer our question of finding that balancing initial investment. All right, so we're going to start with a specific example here, right? Suppose we have an annuity that earns 2% interest, and where we take out $1,000, and we're assuming that these are both done on the same schedule, every month, every year, some consistent time frame. Well, we kind of know how to model this sort of situation, right? The interest is the change in the principal, how much the investment increases by, and this is going to equal 2% of the current investment. Right? So delta P sub n, this is P n plus 1 minus Pn. And if we solve this for P n plus 1, we get our model. Pn plus 1 equals 1.02 P sub n. All right, now that is the increase. Right? Our final model has to take two things into account. Right? Our final model has to take into account the let's call this delta I. That'll be the increase minus delta n, let's say delta D. Right? That'll be the decrease. Right? So what we actually found here was the increase in the investment, and the decrease is actually easy. It's just taking out $1,000, right? So our final model will be P n plus 1 equals 1.02 Pn minus that $1,000. Now, notice that I didn't specify a dollar amount for the initial investment. Right? That's where our question is here. What initial investment do we need so that the balance stays constant? That is, the amount of interest we earn each month exactly equals the amount that we take out. Well, right now, I mean, we don't have any real method of calculating that just yet. So what I'm going to do is I'm going to approach this numerically. I'm going to pick some initial values. I'm going to pick some different values for P sub 0. And I'm going to calculate the numeric solution for our investment using my formula here for those values and just kind of see what happens. Right? That's what I've done on this slide. Right? I took three different initial investment values. I took $60,000 and then used our formula to calculate the investment for the next 7 time periods. Then I did the same thing for $50,000 and the same thing for a $40,000 initial investment. You can see what happens, right? The values are changing for 60,000 and 40,000, but 50,000, this is our sweet spot, so to speak. That is the initial investment that keeps the balance of the account constant. And as we so often do, right? I said, okay, well, let's look at this graphically and see what happens. And you can see how the $50,000 investment does give us a constant balance. So you can see what the other two are doing as well. The $60,000 investment is increasing, and we expect that to continue. In this situation, we're taking out less than we earn in interest. So the principal, the balance of the account, is going to increase indefinitely. And for values less than 50,000, the value of the account is decreasing over time, and presumably that's eventually going to hit zero, and we will have spent all of those funds. All right, so before we move on to seeing how we can calculate these values, we kind of need a name for it, right? What we're looking for is called an equilibrium value, or a fixed point of a dynamical system. And the way this is defined is it's a number A, such that A sub k is equal to that number for all values of k, right? And this A value is A sub 0. That is our initial investment. All right, now we've kind of seen a specific example. We did what we've done in some other lectures, and we kind of approached it numerically. Right? In the next lecture, we're going to look at this analytically and see how we can go about actually calculating the equilibrium value for a given dynamical system.